Yeah, my name's Francis. I'm here with Jonathan, and we both work on the cloud team here at RBC. And yeah, today we're going to be talking about how we leverage Backstage and specifically the scaffolder's concepts to build a workflow engine for our own IDP. And now, for those of you that are not familiar with RBC, just to kind of like set the stage, give a little bit of context where we're coming from. We're one of Canada's largest banks, and we've been focusing very heavily on things like AI-driven solutions and modern infrastructure tooling. And yeah, we're really proud to be on the team that's helping to drive that initiative. And a big way how we're doing that is through our own internal developer portal that's built on Backstage. Yeah, we're super excited to be here. We're looking forward to actively contributing back to open source projects, and especially cloud native and the Backstage communities in particular. And for today's agenda, we're just going to do a quick refresher on Backstage templates. I know everybody here is probably pretty familiar with it, at least 70% of you from the poll earlier, but we'll just do a quick refresher so we're all kind of speaking the same language. And then we're going to dive into some of the challenges that we encountered as a large organization and how we approach those challenges. And then, no pressure to Jonathan, we're going to have a quick live demo so you guys can kind of see it all in action. No pre-recorded video, so hopefully everything works out. And if we have time, we'll do like a really short Q&A. But if not, we're going to kind of just like hang out right outside for a few minutes in case everybody wants to chat or something like that. So yeah, let's just get right into it. So Backstage software templates, or like the scaffolder, for those that are not familiar, essentially a way to create standardized self-service workflows. It enables things like automating bootstrapping code templates, creating new microservices that already fit your org standards baked right in. You can also provision cloud resources, or honestly pretty much anything else. And what we really love about the Backstage scaffolder / software templates, and I'm sure you guys do too, is we get this consistency in best practices baked right in, right? The config is super simple. It's just YAML-based. Try not to throw any YAML at you early in the morning. If you're not familiar with YAML, you're at the right convention for that. So KubeCon's right next door. So, but yeah, anyways, templates are super flexible. They're reusable. You can trigger custom scripts. You can connect to external systems. And they're very easy to find in the Backstage catalog UI. So like I mentioned before, these YAML configs are where we define our template parameters, so things like user inputs and input definitions, validations, stuff like that. And in terms of platform capabilities, there's this notion of actions. Obviously, everybody knows about actions. This is kind of like a way for you to be able to perform things like creating Git repos, provisioning infrastructure, that sort of thing. What's great about actions is that obviously there's a very rich open source community with all kinds of actions, from like Git operations, Kubernetes deployments, Slack notifications, anything else. Another key capability for the Backstage scaffolder is this library called React JSON Schema Form, which we're going to talk about a little bit more later. And this is essentially the library that allows us to generate dynamic UIs based off of these YAML templates. So when a developer goes in, creates a workflow, they don't actually need to like write any front-end code at all. And then finally, we can connect to external systems. Obviously, it's through actions, but we can also inject secrets directly into our workflows. So connect to GitHub and email clients and that sort of thing. So what's the problem? As a large organization, we did encounter naturally some new requirements that were stretching a little bit beyond the scaffolder's core design. We felt like we were encountering a lot of legacy manual processes within our company. We had a lot of multi-step manual approvals where people had to go in and approve or reject requests, sometimes like days later. We also had these complex multi-step automations. They could occasionally fail sometimes. Not super pretty. So we knew that we needed an error handling strategy that could allow us to recover from these exceptions, and not just by starting over from scratch every time. And once again, a little sacrilegious to say with KubeCon next door, but felt like we were maybe hitting the limits of YAML's expressiveness at times. Some logic was getting a little too complex for indentation to solve, so yeah. Yeah, jokes aside, we had some minor concerns around scaling with secrets and having all these secrets centrally in Backstage, sorry. And from an organizational standpoint, we work with a lot of teams, and all of these teams have very diverse skill sets. Extending the Backstage Scaffolder does require a little bit of expertise in TypeScript, and that's fine for most teams. In fact, as a front-end developer, I know and love TypeScript, so not a big problem for me, but I think we need it to be just a little bit more accessible for the platform engineers out there. And so what was our approach? Well, we identified a few key components. So for instance, we knew that we first needed to support long-living workflows that could handle multiple users in the loop. We wanted to be able to kind of like pause and resume these workflows, sometimes days later, where like a DBA might have to come in and hit approve, and then like some other customer experience manager has to hit approve as well, stuff like that. And then if any issues did happen within these long-running workflows, we wanted to be able to route these exceptions back to our incident management systems. So how did we do that? Well, we decided to integrate with an event-driven workflow engine. Jonathan's going to go a lot deeper into this, but what's really great about this approach is that it kind of gave us built-in retry, rollback, and cancellation capabilities. And more importantly, for us anyway, it allowed us to decentralize workflow execution and secrets management. So that way we could kind of like execute automations and store our secrets a little bit closer to where they're actually needed. And then finally, this was like pretty crucial for us from an organizational standpoint, like I mentioned. It allowed the teams we work with to be able to independently build automation in any language that they were comfortable with. So now I'm going to pass it off to Jonathan. He's going to go a lot deeper into this.
All right. Great. Thank you, Francis, and thank you everybody for attending early morning on the Monday. All right, so going a little bit more deep dive into the technical architecture side. So this is kind of revisiting the kind of vanilla Backstage, how it's operating today. You have like the YAML templates and then the Backstage capabilities, all kind of centralized within the Backstage platform. Basically, you deploy one thing, it has all the capabilities built inside of it. The way we approached it is that we made a couple modifications. So we expanded the YAML configurations with kind of Golang support around it. So let's say you need to collect data input. All of that's still configured through React.json schema, but then all the actions configuration for parameter passing, transformation, stuff like that can be articulated using Golang. So you can call any native functions to like, string concatenations or uppercase, lowercase, that type of stuff. And then from a platform capability perspective, we're preserving the React.json schema form. We really like that library to be able to, define what user input capture you need without having to script a whole bunch of JavaScripts, especially working with a bunch of platform teams that they really have minimal UI experience. They just want to say, hey, ask the user certain things, so we can just configure that without asking them to learn, React, JavaScript, TypeScript, all those things. Cool. And then the next level is that we're decentralizing the workflow state out of Backstage into an independent workflow engine. The workflow engine is responsible for maintaining the workflow state, support event-driven Saga patterns, so we can monitor the event history and be able to perform rollback and continuation, pause, things like that. I'll talk about the workflow engine a little bit more. And then most importantly, for troubleshooting purpose, the workflow engine gives us a kind of unified UI, so you can see where things are progressing from both a user and a system-to-system perspective as well. And then finally, to integrate the actual implementation, we have the workers that talk to the workflow engines to perform the actual logic. So some of the workers may be like, because we're in a hybrid cloud team, we have workers for like talking to AWS, Azure, and then each worker will be responsible for executing the specific task as part of that workflow. And then because it's decentralized, the secrets is with the worker and not all the way up in Backstage. So every team can manage their own workers, write it in their own language, and manage their own life cycle of the workers without kind of going back to the Backstage kind of centralized team level to say, hey, I want to change the logic. Can you change it in TypeScript and then redeploy Backstage and holistically? So it's more independent life cycle between the Backstage and the actual business logic. All right, so a big part of the integration here is all around the workflow engine and which one to use. So if you explore the kind of ecosystem of workflow technologies right now, there's a lot in the market. I think there's a GitHub page with like 60, 70 workflows, engine types that you can kind of look at. The way we approached it was that we kind of came up with this list of key considerations we need to support it from a capability and a different factor perspective to narrow down the list to make it appropriate for us. Key things is like we need to have a workflow engine that can run for multiple days and have human in the loops. You may be familiar with workflow engine like Airflow that you can start, run 5 tasks, automate it automatically, but finish within 5 minutes. But we need to be able to pause that workflow and wait 2 days and then continue on from there. So that's a key requirement for us. And then, having an easy-to-use administrative UI so we can, for troubleshooting and incident management, that's really key. And, be able to define your workflows as code versus BPMN, that will be another consideration. Also, like in terms of hosting options, it really depends on your organization. For us, we want to be able to have this workflow engine portable between the different cloud platforms and not be tied to a single cloud provider. So that may be a consideration for yourself. And obviously, scalability, licensing costs. So some candidate technologies, if you look in the CNCF ecosystem, Dapper workflow and Argo workflow, I think kind of meet some of the core criteria. For us, we chose to go with the Temporal. We're using the open source version, but it also provides all these capabilities. Azure Durable Functions and AWS Step Functions provide similar capabilities, but a little bit more tied in with the specific cloud providers. And then Kamuna for more kind of like legacy BPM and approach to this. Okay, so that's the slides. Let's jump into the demo. And fingers crossed for this part. I'm going to start by actually introducing. Am I not sharing screen? Oh, I think I need to exit out of this. Okay, so I'll just start by introducing. This is the Temporal UI. This is the specific to Temporal, but this is where you can actually see the workflows that are running. And the reason I'm bringing this up is I'm actually going to park this on the side of the screen, and then as we walk through the UI from a Backstage perspective, we can see how the Temporal workflow engine side maintained all the states here. So this is the Backstage UI. I'm sure you are familiar with it. So out of the box, this is the kind of built-in templates view. What we have done here is introduce a workflows view. And this is where we provide a similar experience where you can see all the templates or workflows that's provided from the platform, so developers can come in here, see what workflows are available, and then initiate from them. For our team specifically, we're hybrid cloud, so our focus is really around provisioning hybrid cloud resources, either from Azure, AWS, or GCP, and then having workflows for, let's say, triggering DR events like cross-region failover or triggering cost optimizations, be able to monitor what your resource consumption is, and then be able to tune that or scale it down. So those are kind of like the key workflow business use case that we have. And then what we want to do is provide a unified experience for developer to initiate these workflows. For this demo purpose, I'm going to go with something super simple. We're just going to provision a database against a database server that's running on my local, but it will highlight a lot of these concepts. Cool. So you can park this on the side here. So I have, yep. So I have Backstage on the left-hand side and then Temporal on the right-hand side. We'll see how kind of these two systems interact. So I'm going to start with triggering a new database workflow. And then here, the use case is I need to provision a new database. So I want to put in the database name. Select the environment. I'll put in dev. And then let's say I want to put the database on a solid-state drive. And I need like 400 gigabytes of quota on this. And what you notice right away is that the workflow itself is already backed by Temporal. So as soon as you start the workflow, a new workflow on the Temporal side gets registered. And all the user inputs is logged within the event logs within Temporal. And when I click submit, the submit user action is registered as well. So here we have like a single view of all the user clicks that are happening, and we can register that and perform metrics against it. Okay. So after I submitted the first form, I can perform calculations on, let's say we estimate the monthly cloud cost. Let's say, based on your storage requirements, it's going to cost $4,000 per month. I was like, okay, that's too expensive. Maybe I come back here and then, change the cost a little bit. So this is where and then in this case, the cost went down from 2,000 down to 500 as an example. And that's one example of like using Golang to drive business logic and the power that gives us. Okay, so at this point, I'm happy with the cost and I'll submit it. And then the next stage of the process is that DBA needs to approve this before the database gets provisioned. Because all the states here is maintained in Temporal, we can actually get out this workflow state and then come back and resume it. So all the user inputs is stored in the backend, and then where you are within that workflow, all of that is tracked in Temporal. So as a DB, I come here, I review everything, and I hit approve. So this is where the automation actually gets triggered. It's on the right-hand side, you can see that the user actions happen, and then the actual create database workflow gets triggered here. And then from a user perspective, you see the form is submitted, but then the database action is pending. And then if I look into the workflow side, we can see that, okay, so the database child workflow is running, but there's an error happening down here. So within a single UI, you can see where it is in the execution history and where the errors is, but the user doesn't have to know about it because from their perspective, they submitted the form, but we just need to fix the automation part. So as an administrator, we can see here that, there's a connection error to localhost because the authentication error doesn't, password is wrong in this particular scenario, but you can imagine could be network issues or things like that where you may need to see the error and trigger retries and so on. That's all baked in. In this case, so this is the Python worker that's actually connecting to the database and then creating that database. So in this case, as you can see that the password is wrong, so I'm just going to switch this password here, a single hand. And I'm going to do Okay, so I just restarted the Python worker, but from a temporal perspective, it knows to retry that activity, and it was able to continue on. So it picked up the new password. We didn't touch anything on the Backstage side. The worker picked up the new password and was able to create the database. And we can see that from PG admin that the new database is now provisioned at the actual infrastructure level. Cool. So from back on the UI side, we can see that the automation continues on. The user didn't need to resubmit the whole request due to like a sporadic intermittent errors, and then we're able to resolve the issue and then continue the workflow without any user intervention, like end user intervention. So at that point, we execute a sequence of automation, but circling back, you maybe actually need to loop back to the user and do more actions. So as a follow-up to creating a database, you may want to do something like integrate the new database with an application. So this is like more future-facing, but we'll be looking at, let's say you have a handful of applications you already have GitHub repos for, but you want to integrate with the database. So let's say you have a Java app, a Python app, and Node.js. You may want to select the a subset of applications and then submit this. Same concept, you can trigger like more automation down the road. We're imagining things like integrating with Copilot to analyze the GitHub repo structure, make any code changes, configuration changes to the repo structure, push it on behalf of the application teams, apply any network Kubernetes settings that require to connect the application to the database, and trigger and redeploy of the whole application. So all of that would be enabled through kind of like the combination of Backstage data collection with temporal-based event integration. So that's the end of the demo. Thanks so much. Okay, I think we have a few minutes for Q&A. Have anybody got any questions?
I guess I don't know if we'll hear you super well.
Yeah, you mind yelling at us? Yeah, if I'm hearing the question correctly, it's like, what are we using to enforce the policy for infrastructure provisioning?
Yep.
Yep. In real life, we're actually going through multiple layers first before we actually call the Azure API. So what we're doing here is like Backstage is collecting information, but we're passing that down to infrastructure as code. So we're actually writing to Terraform repo, create all the resources there. Terraform Enterprise deploys it down to the actual like Azure, AWS, and so on. But for this demo flow, I'm simplifying it.
I see. And for the approval or any GitOps operation that you might have to do, is that through the Terraform, I don't know, Terraform Cloud or?
Yeah, so any approvals, I mean, in a real life scenario, we already have multiple approval systems. So like, ServiceNow is one of them, or like, Jira and things like that. So, using Temporal, we can orchestrate with the source of truth for that approval process, or, we can bake that into the workflow itself. So just by having an event management system, we can integrate with any source of truth for who the approver is and where that system should exist.
Okay. Yeah. I see. But everything's all through that shown in the workflow engine.
Exactly.
Okay.
The temporal UI really is that single pane of glass to see all the integration points from the user to system back to user. So that really is really powerful from our experience.
Thank you.
Thank you. Question on this side?
So we have a lot of the same issues that you mentioned before. And I was wondering if you're making these available to people, or just internal for you?
That's a really great question. At this point, this is strictly internal. The purpose of this talk is actually to share what we have done, and depending on the feedback we get, we think we'll be looking at ways to contribute back to the community, maybe by code or by contribution by other means.
Wait for us to gauge interest.
Yeah, exactly.
Have y'all completely moved off of the scaffolder, or do y'all use both the scaffolder for some things and the workflow engine for others?
Yeah, that's a good question. We use Scaffolder for application repo deployment. So let's say you create a new Java app, Python app. So we're still using Scaffolder for that, where it's a little bit more simple in one shot, and we're okay if the user retries. But for something more complicated, like multi-step approvals and more error-prone type of integration, we're moving towards like a temporal-based workflow.
Okay.
Two questions. Just from a secrets management, you mentioned like secrets injection. What are you guys using on the back end to do that injection, if you don't mind me asking? And then any particular reason you chose Temporal over like workflows or some of the other options?
Yeah, that's a really good question. So the actual secret management depends on the cloud provider. So like if it's AKS, will inject it from AKV, so it aligns with whatever enterprise secret best management practices. So from a temporal perspective, that's pretty agnostic. Ultimately, it's the worker to the secret key store. Why did we pick Temporal? A few key reasons. They have an open source offering that we're using right now, so we're not paying SaaS, and it's also multi-cloud hosted. We're just running within Kubernetes. Easy to deploy. It's just running Temporal running on a database. Doesn't require like separate Kafka topics, stuff like that. So it lowers the infrastructure requirements. And then also from a current customer use case, they're actually being used by major customers. I'm not going to repeat all of them here, but if you take a look at their current deployment scale, it's actually really impressive. I think it will scale nicely with our ecosystem. And then actually one final benefit is that the worker implementation, it supports Polyglot SDK. So right now we have temporal workers in both Java, Python, Golang, and supports other languages as well. So it gives us that kind of anybody. If you know Java, you can integrate. If you know Python, you can integrate. If you have existing API, you can integrate. So that kind of gives us that integration capability.
Hello, I have two questions. Thanks for explaining the earlier question. The Temporal are integrated through plugin, or do you guys have some different way to integrate it into that Backstage?
Yeah, that's a good question. So how did we actually integrate Temporal to Backstage? So the one thing I'm kind of didn't include in the diagram is actually I have a thin layer of, I guess, interface. So it actually is responsible for integrating with Temporal and then providing REST API to Backstage. So that's responsible for showing the React.json form schema, but then also provide like submit and get state status. So Backstage doesn't directly talk to Temporal, but through a kind of like adapter layer, I guess you can call it like that.
Almost build like a plugin that just
Yeah.
interfaces with it as well.
Yeah.
Is there any multi-tenant approach, like everybody see everything, or is there a different UI for an users login from different tenants aspect? So the temporal is same for everyone, or do they have a different view when they log in?
Yeah, I guess in terms of Temporal RBAC, it's up to you to configure. Temporal has within it built-in concept of namespacing, and you can build custom authentication to say, users from this AD group can see this namespace. So it's highly customizable for your organization need.
Maybe time for one more.
Good morning. Whoa, that's loud. So I have two questions. One is, how big is your developer community at your company? And then second, when it comes to your automations with your scaffolds and your workflows, do you only manage it with one team, or are all teams supporting it and having an inner source model? And how does that work for you guys?
That's a really good question. I think if we look at the RBC developer community, I want to say 1,000, 2,000 developers, maybe even more.
Probably more, just within cloud, we're talking
Yeah.
about like.
Okay, vaguely speaking, we're looking at, so we're a cloud team. We have about 1,000 applications sitting on cloud, and I think you can make some assumptions about like each application is supported by a handful of developers. So I think we're in the order of thousands in terms of total developers. For our workflow specifically, right now we're kind of starting with just the platform engineering side. So exposing cloud capabilities to teams that require onboarding to cloud. So right now, people contributing workflows here would be in the scale of tens, where each platform team can integrate their workflow into Temporal, so we can expose that capability to the app teams. So that's the kind of ecosystem we're operating on.
We might be out of time.
Yep.
We'll be hanging out back if anybody has any questions for us, but otherwise, thanks a lot.
Yeah. Thanks for your question.